Hi, this is Miss Logan. Today we will be talking about friction and how we will be able to use the friction equation in force problems. Okay, so first, what is friction? You've probably heard of the word. You may have even discussed how it affects us and what causes it. So friction is a force present whenever an object moves or attempts to move that opposes the motion. So we saw this in our free body diagram. If I'm pushing a box to the left, then to the right, my friction force is opposite. This is affected by a couple different things. First, the material of the surface and the normal force, which we'll get to what this actually means in a minute. So there are two types of friction that we will be discussing. First one is the static friction. This is when the object is not moving. This is the minimum force needed to overcome a threshold so it actually will begin moving. So in problems, this will say, what friction do I need to get an object moving? Kinetic friction is when an object is already in motion. This is always less than static friction. As you may know, if we are pushing a heavy box, it's harder to get it started than it is when we're actually pushing it. That's because our static friction is greater than our kinetic friction. So the formulas we're going to use, they all boil down to our force of friction is equal to mu times normal force. Easy way to remember this? Fun. That's our equation. So for static friction is equal to the coefficient of static friction times the normal force. Kinetic friction, or friction kinetic, is equal to the coefficient of kinetic friction times the normal force. All I'm doing in each of these problems is changing this subscript right here. It's the same formula though. Force of friction equals coefficient times normal force. So how do I calculate normal force? Well, if we think about a box that is sitting on a table, I have the force of gravity that's down, and I have normal force up. We know that these two things are equal to each other. Remember that our force gravity is actually the weight of the object. How we figure out the weight? That's mass times gravity. So how I find my normal force on a flat surface only is taking my normal force is equal to my weight, which is mass times gravity. That's what we'll be using every time to figure out our normal force on a flat surface. All right, so Gabe is pushing a refrigerator box that has a mass of 135 kilograms. If the coefficient of static friction is 0.47, what is the minimum force he needs to move the box? So think to yourself, what am I looking for? I'm looking for static friction. So what do I know? I know my mass is equal to 135 kilograms. I also know that my mu is equal to 0.47. Let's write out our equation right here. Let's first find my normal force. So Fn equals 135, sorry that wasn't right, times 9.81. So I'm going to get a force normal equal to 1,324 newtons. Now I can plug this into my equation. Force of friction equals mu times 1,324 newtons. So my force of friction to get this thing to move is going to be 622 newtons. So this static friction right here is always less than 1. So it should be, for your answers, less than 1 and a decimal. All right, so if the coefficient of kinetic friction is 0.35 and Bree pushes her friend in a chair with a mass of 100 kilograms total, how much force is she using? So remember, we always need to start out with what I know. I know my mu is 0.35. My mass is 100 kilograms. And I also know my gravity is 9.81 meters per second squared. So I am looking for kinetic friction equals mu times force normal. All right, so another way I can solve this is to just plug all of these numbers in. So 0.35, remember, force normal equals mass times gravity. So I have 100 times 9.8. So for my force kinetic, I'm going to have 43 newtons. All right, so please work on these follow-up questions, take a picture, and upload them to Google Classroom by the due date, which is Thursday.